Okay, so today we're going to look at atomic structure, and we're going to start trying to figure out how we get the number of protons, electrons, and neutrons in each type of atom, so that we can determine those things and then actually draw what's called a Bohr diagram for them. So this is how we're going to figure out atomic structure. I guess the first thing we're going to look at is just even some properties of elements. So, for example, here's a simple question. We make bikes out of aluminum, and lots of times graphite and things like that now, but we don't make bikes out of gold. Now, why? Probably the obvious answer is cost. I mean, obviously, if you made a bike out of pure gold, it's going to be very, very expensive. But the other thing about gold is that it's actually not very strong in the sense that it's malleable, it's bendable, it's shapeable. If you built a bike out of it and you sat on that bike, the bike would probably warp and bend, because it's not as strong as other metals. It actually, it bends really, really easily. Now, it also has a lot different weight. Gold is very, very heavy compared to aluminum, which is very, very light. So these properties are the reasons why we choose things like aluminum to build bicycles or car parts or things like that out of, and not gold. Not only just cost, but it's the weight, it's the durability and the strength of the substance as well. So same amounts of these substances will have different masses and different properties, and there's reasons for that, and it actually comes down to the parts of the atom. And every element has unique properties that are unique to that one element. So, like I said, aluminum and gold are very, very different. They're both metals, but they're both very, very different. And the differences have to come from somewhere. So different elements will look and behave differently. And since all atoms are made of three things, protons, electrons, and neutrons, it must be the numbers of these things that are affecting the difference, or causing the differences in the different elements. So, depending on how the atom is put together, we're going to get a different property, I guess, is what I'm trying to say. Now, before we get any further, we should talk about standard notation really quickly. It's just the way that chemists will often write their elements. It's actually the opposite of your periodic table. Don't ask me why, but it is. And this is kind of standard notation. So you'll write the element symbol, then the mass goes up kind of above, and the atomic number goes there. So these are the things that we need to understand, or we need to know. So we've been talking about the symbols for the last little bit. Now we're going to be talking about the atomic numbers and the atomic masses. And when we were working with our atomic masses, for now, we're going to be rounding those numbers to the nearest whole number. So if it's 5 or higher, like decimal 5 or higher, we would round up to the nearest number. If it's decimal 4 or lower, we would round down. And like I said, on your periodic table, it shows it more like this, where the atomic number is the top number and the atomic mass is the bottom number. That's more typical. So the way I remember it is the mass is always heavier, because the mass is made up of more things. And we'll talk about that in a second, too. So using those numbers, the atomic number and the atomic mass, we can actually, that's all we need in order to figure out what each element is made of. And the atomic number is the most important one. It's the number that tells us the number of protons an atom has in its nucleus. So every element has a specific number of protons. When we were talking about the alchemists, they were trying to turn things into gold. Well, if they could take elements and fuse them together, take protons and push them together into a nucleus, and get a nucleus with exactly 79 protons, that would be gold, because that is the atomic number of gold. This is the number that identifies the element. So every element has a specific number of protons, and that's what makes it that element. So an example is carbon. Carbon is atomic number 6, so it has 6 protons. Lead is atomic number 82. It has 82 protons. Carbon and lead are two very different chemicals. They're two different elements. Carbon is much, much lighter than lead, obviously, because it only has 6 protons, whereas lead has 82. Lead is quite heavy. And also they have very, very different properties, and they're just different things. So on the periodic table, the atomic number is basically the number that identifies that element, and all of the elements are arranged in order of their atomic number from left to right. So you start with element 1 is hydrogen, then 2 is helium, and 3 is lithium, and 4 is beryllium. 5 is boron, and so on and so on and so on. And every element just has one more proton than the one before it. So the number of protons is always the easiest because the periodic table is trying to tell you that number right away. Now, we learned earlier that the two heavy things in the atom are the protons and the neutrons. So the mass comes from the mass of the protons and the mass of the neutrons together. And that's really what our atomic mass is all about. Remember, we say that electrons basically weigh nothing. So if we know the mass of an element, and the number of protons, we can figure out the number of neutrons. There's a little formula here that we can use. We don't really need to use it because we can kind of rationalize this out. Notice that the mass of the atom does not include the number of electrons, since the mass of electrons are so small. They basically don't count. So here's an example. Nitrogen. If you look up nitrogen, it has 7 protons. Well, nitrogen also has 7 neutrons. And if you look it up, its mass is 14. Well, why? Because you have your 7 protons and your 7 neutrons, and then the total mass would be 14 AMUs. So if we know the mass of an element and we know the number of protons, we can find the neutrons. And you will always know the mass and the protons because you know the atomic number and the atomic mass. So here's kind of some examples of how to figure out the number of protons, electrons, and neutrons. So first one we're going to do is, let's say carbon. We're going to look up carbon on our periodic table. And carbon has atomic number 6. So its atomic number is 6, and its atomic mass is 12. So once we've found carbon and we've got these two numbers now, we have all the information we need to find protons, electrons, and neutrons. The atomic number tells us the number of protons. So since the atomic number is 6, it has to have 6 protons. Now, the one thing we haven't talked about yet is the electrons. Now, remember that protons are positive. Oops, my pen's not working. So remember that protons are positive. The electrons are negative. So for an atom to stay neutral, in other words, to have the same number of positives as negatives, we need to have the number of protons and electrons be the same. So if carbon is neutral, that means it has 0 charge. If it has 6 positives, it needs to have 6 negatives. So carbon would have 6 electrons. And for all of grade 9, it's always going to be the same. Protons and protons and electrons will be the same because all of our elements are going to be neutral. Now, the hardest part is finding the mass. Now remember, the mass is the number of protons and neutrons because those are the heavy things. So since the atomic mass is the number of protons and neutrons, unfortunately I can't write on my screen, but we know that it weighs 12. So of that 12, 6 of it is protons, so the other 6 is neutrons. So this is carbon's number of protons, electrons, and neutrons is 6 protons, 6 electrons, and 6 neutrons. So here's another example, and one for you to try. So give it a try, go through the steps, and then you can pause the video right now, and then hit play again and see how you did. Okay, so looking for potassium on our periodic table. Potassium is atomic number 9. Oops, back this up. Try that again. So we're going to do this. Atomic number 19. And its atomic mass of potassium, if you look it up, it's the bottom number. It's 39.1. So we're going to round that to 39. So the atomic number tells you the number of protons. Potassium must have 19 protons, which means it must be neutral if it has 19 electrons. Remember, protons are positive, electrons are negative, so 19 positives, 19 negatives adds up to 0. Now, if you think about the mass is 39. If this is going to equal the number of protons, which we already know is 19, plus the number of your neutrons. So we can think about 19 plus what is 39. In other words, 39 take away 19 is what? And that leaves us 20. We have a mass of 39, of which 19 is protons. The other 20 has to be neutrons. So now we can list them out. This is 19, this is 19, and this is 20. So on the next page, I would like you to try to fill out your elements and their symbols, and then list the atomic numbers, number of protons, number of electrons, then the masses, and then find your neutrons. And then I will post up the answers in a minute. So here are the answers for all of the elements, the first 18 elements of the periodic table.